Hello, this is Nagesh Rao, learner at Coursera. I'm doing course on machine learning foundation for product management. As a part of this course, we have to complete an exercise where we need to create a model based on a set of data which is provided in CSV format. Basically, we need to predict electrical energy output in a combined cycle power plant. The data consists of 9,568 hourly readings collected out of various sensors, that is temperature, ambient pressure, relative humidity, exhaust vacuum, net hourly energy output, that is the PE. Out of the given options for arriving at solution, I have picked up AutoML as this is something new to me and of interest. We use supervised learning, that is regression model, to address the problem. The reason for this was we have the previous data provided along with the label, and the predicted value is continuous in nature. The output metric is the PE. We have created two models. Um the first model was generated using all the features available, that is temperature, ambient pressure, relative humidity, and exhaust vacuum. And based on the result, we have created a second model where we have reduced the features. We have used only two features, that is temperature and vacuum. Related to the algorithm, we could not consider any algorithm as such because AutoML does not allow you to do so. Um, it is all internal to AutoML. The algorithm they select is automatic and it is something like a black box to us. And the data we split into three parts: the training data, validation data, test data in the ratio of 80-10-10, and we used fixed validation set. Now let us have a look at the AutoML models created. Here is the Vertex AI dashboard, and as you all know, AutoML is part of Vertex AI, and we will quickly go to the dataset which I have already created um, by uploading the CSV file to the cloud in a bucket and then importing to AutoML. One thing we have to take care is that the target column should be clearly labeled, P in this case, and we can see the details of the column, okay, by clicking to the respective column. So let us go quickly to the models which have been trained, and if you see there are a lot of models we have created, but let us pick the best among them. So version 2 is the model which I was referring earlier as model 1, uh, and the details are here. So this model has been created with balanced features, taking all the features and in a balanced way, equal balance. And then the target column, as you see, is P, and the data has been split as as per it is randomly assigned into 80-10-10 ratio. And algorithm, if you see, is been mentioned as AutoML, interestingly, because AutoML does not tell you the algorithm what they are using for the model. Okay. And the objective is tabular regression, that is regression on a tabular data. And we have optimized model 1 for RMSE. So let us quickly evaluate and compare with the other model which I have created. Okay, so model 1. So model 2 has been created with only AP and V as the feature. If you see, it is here. And if you highlight this, it will tell the final weightage what has been taken. Okay. And coming to the various parameters, that is MAE, MAP, RMSC, we see that the model 1, that is version 2, is quite good in these parameters, which includes the R square. R square, as you know, it has to be closer to 1, and it is 0.96 in this case, which is very good, and it tells how well the model explains the variance in the target variable. So other than R square, okay, all the other parameters, the lesser the better. Okay, so you can see the model 1 is quite good. First of all, as a standalone, it is quite good, but at the same time, while we compare with model 2, it is very good that way. And we should decide on model 1, that is version 2 here, to go for production, and we can test it there. Thank you.